without further ado, so I would like to quickly go through with the UNESCO program in 1 or 2 minutes, and then we will formally start our lecture. All right, so our center is blessed by UNESCO, the prestige we have got through establishment of a UNESCO chair on medicinal and bioorganic agricultural chemistry just in 2019. And what is the basic, program of UNESCO chair is basically to promote international inter-university cooperation and networking to enhance institutional capacities through knowledge sharing and collaborative network. So that's why UNESCO has developed this program for networking of different science institutions around the world. About 170 of the university chairs included in the UNESCO chair, which are related to the natural science. So the objective of UNESCO chair is basically to linking researchers and practitioners together and research and training of the young scholars and teaching programs and inter-university network. So iccbs has got this recognition back in 2020, when the agreement was signed, and our current director, Professor Dr. Raza Shah, has been appointed as UNESCO chair just last year after completing the tenure of Professor Dr. Bal Chaudhary. So with that, I just conclude my UNESCO intro. Now I would like to introduce uh, 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 our our presenter today, who is none other than Professor Dr. Geoffrey Cordell. He is one of the pioneer in the field of natural product chemistry. If you go around it and search about him in the Google, you will find thousands and thousands of topics he has been discovered and talked about during his whole journey of career. So I would like to briefly say about his introduction. He has completed his PhD back in 1970 from Manchester University in the field of natural product chemistry. So you can imagine like over the decades of experience he has in the field. So you can see the talk is going to be very interactive in such a manner. He has been working for much of his life in University of Illinois at Chicago, where he has served about many capacities. For example, he was center director, dean, and assistant vice chancellor also. He retired in 2002, but since then he has been active in different fields, different domains of natural world chemistry and different institutions. So he has about over 620 publications on his credit. He has been author of many books in the field of natural product chemistry and alkaloids. And he has been always instrumental in the research program from the NIH and NCI in the field of cancer, malaria, and other kind of diseases for finding the drug discovery from the field of natural chemistry. And he has academic impact in number. He's about 31,400 citation over his credit, and he has an H index of 83. So today, Professor Geoffrey is going to talk about a very important topic, that is future role of natural world in medicine and security. So Professor Geoffrey, over to you. Thank you so much.
Thank you very much. Let me just get this sorted out. There we go. All right. Good morning, everybody. Good morning. And thank you again for the nice introduction. Thank you again for the invitation. I feel greatly honored to be with you this morning for you and late evening for me. I'm going to talk to you a little bit today about this subject of the future role of natural products in medicine security. And probably you haven't come across, most of you, that term, medicine security. We're going to see what that means. And what I want to focus on here is I want to take you on a journey. I want to take you on a journey into the past and also a journey very much into the future, because this is really a talk for the young people who are going to be making a difference in the future. The people who 5, 10, 15 years from now are going to be leading natural products research. And we've got some major challenges, and we're going to talk about some of those here today. Oops, sorry. So as was mentioned, I'm trained as a synthetic organic chemist.
Professor Geoffrey, please share your screen.
I'm sorry?
You forgot to share your screen.
Oh, somehow it got deleted, that sharing of the screen. Hang on, let me go back here. No, I thought it would go because it was right there in the background. Just hang on a minute.
Mhm.
Why is that not coming up now?
Yes, it's now shared.
Now it's sharing? Okay, thank you for
Yes.
that. I appreciate it.
Can you
Sorry
make
about
it
that.
like
I thought it was going to
light
come back
presentation?
automatically and it didn't. All right. Okay, so here we are. Let's go back to this screen. Yeah. So,
Good.
so as I was saying, so I was trained as a synthetic organic chemist and did a lot of work, obviously structural elucidation and some synthetic work and so on, and various types of natural products, as you know. But then a few years ago, I kind of flipped around. And rather than thinking about aspects of discovery, because I did a lot of work on drug discovery for many, many years, from mostly from plants, um, I decided to take it from the other direction. And the other direction means putting the patient first. In other words, it's asking what is it that the patient needs in order for them to be treated effectively. And we'll discuss that a little bit. And then we're going to talk about what's going on in the world at the moment in 2025 and how close we are to what I call the edge. And I'm going to introduce you to a few acronyms in this lecture and hope you enjoy them. One of them is the edge. We'll get to what that is. Um, Also, over the years, I've evolved kind of a new natural products lexicon that we're going to talk about. That's kind of ended up with medicine security and love. And we'll discuss what those are about. And then finally, we're going to talk about natural products in 2030 and beyond, and really the exciting challenges that lie ahead for us, and particularly some new strategic thinking about how we approach what's going to be needed for the future. So, what's putting the patient first? Well, a healthy people require a healthy earth. And one of the things that we're not working too well on at the moment is maintaining a healthy earth for people to work with. And we've seen, obviously, with the COVID period, that you can easily, it really demonstrated how fragile our system is globally when you have a pandemic like that destroys local economies and some major global economies for long periods of time. So healthy earth is really critical. And healthy earth means that we're using the earth to create healthy people, to maintain healthy people. So let me just go back. Sorry. So big pharma, the major pharmaceutical companies, are not going to be solving a lot of the major disease problems in the world. We know this very well. This is nothing new. But there's many diseases that are not going to be touched because that's not what they're interested in. And so we're going to come back to this issue in terms of what's the responsibilities of nations to look after themselves or collaborate with other nations in terms of regional initiatives. So interdisciplinary collaboration and dollars are money generally and needed to conserve the environment. It's a big issue. We'll come back to that and alleviate the global and local disease burden. And remember in all of this that we are patients, all of us. So let's ask a simple question here. Well, what is it that we expect in a product? And one of the problems that we have is this issue of all of the groups operating together, the government that funds research, natural product scientists working with industry, and then a retailer practitioner who is delivering the drug to the patient. But you put the patient at the center. You make the patient the focus of what we're trying to do here, particularly when it relates to the issues of quality control. And this notion of QSACA breaks down like this. Whoops, I'm sorry. that patients should be assured of quality, safety, efficacy, consistency. Consistency is really important. Think chocolate, think coffee, think tea, think anything that you take on a regular basis. What does that mean? You're doing it based on the consistency. Patients expect that with their medicinal agents. That's a challenge when you're dealing with, for example, a traditional medicine. Accessibility means availability. Is that product available? And affordability. Can the patients afford the products? Now, we have a very serious core question. And this applies to all of medicines. It's this. As we look into the future, in 2040, what will be the origin of medicinal agents? All right? What will be the origin? Where are they going to come from? And then in 2050 and 2060 and beyond, where are they going to come from? And remember how long it takes to develop a medicine and get it approved. Go through all those steps of formulation and pharmacokinetics and clinical trials and so on and so forth, if that's going to be your process. So this becomes a very core issue. And for whose world are we doing it? Are we doing it for the developed world? Or are we doing it for all of the world? We should be doing it, obviously, for all of the world. We have to have a holistic approach to this. How do we do that? How do we do that? What are the resources, both physical, human, facilities, et cetera, that are needed in order to accomplish that, in order to maintain medicines? So what's going on in the world? Well, we've got a lot of issues, and some of them were discussed in Bioscience 2022, that relate to, and I'm just going to talk about one little aspect of climate change. The increasing carbon dioxide levels, the loss of the Greenland ice mass, and more seriously, with the loss of the Thwaites Glacier, which is an ongoing process, the loss of the Antarctic ice mass. So for 26 years, Greenland and the Antarctic have lost ice annually. That's from the United Nations report. Whoops. I'm sorry. I don't know what's going on here. So we know that some of the major challenges that we've got in the world are drought in various parts of the world that are having major effects on crops. We've got flooding that are having a major effect. We've got fires. We've seen those in many different parts of the world where there never used to be fires. Canada is experiencing some. We had major fires last year. And of course, there's the major issue of pollution. And I was just reading an article a couple of days ago about the pollution issues in the Himalayas now, of being able to actually see the mountains some days. So, yeah. So 2024 was the hottest year in the past 170 years. Every month was above this 1.5 degrees C, which came from the Paris Accords and was supposed to be an upper limit. It's not an upper limit. Clearly, we're beyond that 1.5 degrees C, and that's why there's been this very serious concern now. And you see here the changes that have occurred in the last 80 years. And how rapid that change has become in the last 10 or 20 years. So let's have a quick 2024 status report. Closing in on the planetary tipping points. We'll come back to that in a moment. Global climate is changing faster than expected, and the climatologists can't seem to explain this. The Antarctic ice shrank to its lowest level in 2023. We don't have an estimate yet of what happened in 2024. 2024 was the warmest ever recorded year. Let's say that again, the warmest ever recorded year. 2025 is going to be probably higher, warmer. We've got enhanced economic inequality locally and globally. Rainforest destruction is slightly reduced, but the weather events based on the climate change are increasing in intensity. This is what we're facing. These are the challenges that we're facing now and are not going to go away. So The question, and we've still got population increases. So why should we be concerned about this? Because this is it, folks. This is it. There is no planet or plan B. And our resources are finite. We have to remember this. This is the key. This is the key to the future, because it's not just about us. So in the UAE in December of 2023 was COP28. And I'm not going to go through the whole shenanigans there, but there were 4 not so good global outcomes that came out of that meeting. One of them was transitioning, and that was, I'm quoting here, transitioning away from fossil fuels in energy systems. Well, what does that mean? It means that over time, and there was no time frame put on it, that we'll be moving away from using fossil fuels as the major source of energy. But of course, they're used for a lot of other things. They're used for basic chemistry, basic finding the chemicals that we need on a day-to-day basis for all kinds of different products in society, including medicinal agents. There was a blind spot in this discussion. The blind spot was animals and the methane gas emitted by grazing animals, mostly beef. There were no timelines, there were no benchmarks, there were no investment goals that were associated with this, which there obviously should be. And it was clear, even at that time, that the 1.5 degrees C limit from the Paris Agreement was dead. Wasn't going to happen because there was only going to be by 2030, so that's just 5 years from now, a 2% drop in emissions, which is really nothing. It gets worse in the sense that I'm sure many of you are familiar with the issues of the Sustainable Development Goals. So in Nature in 2024, there was a report that dealt with this and the relationship of what was going to be achieved with respect to the Sustainable Development Goals. None of the 17 goals will be achieved by 2030. This was the program that's supposed to achieve all these goals in the period 2015 to 2030. That's not going to happen. Only 12% of the 169 targets, so within those 17 goals were 169 targets, only 12% of those they might be met. And one of the major examples was given that 2.2 billion people on Earth, which is about just a little less than a quarter of the people on Earth, still lack access to safe drinking water. So when you have a major goal like that, you know that other goals are not going to be achieved. Why were we in that case? Well, methodologies and standards were lacking for 40% of the targets. And 1/3 of the countries are not generating data, or they're not aligning their data with other goals. In other words, there's conflicts between the goals. So what happens next? So there was a UN Summit of the Future in September of 24 to address this concern that the SDGs were not going to be met. And what did that deal with? It developed a pact for the future. And I'm not going to go through all the details, but clearly one of the efforts that came out of this was that much more effort was needed to achieve the SDGs and that needed actionable commitments. It was also the issue of accelerating support for renewable energy transitions. So renewable energy transitions also means taking away the ability to create the chemicals that we're going to be needing for many different purposes, including developing medicines. In October, so the following month, there was the UNEP emissions report. And in the UN emissions report, in the introduction, the UN Secretary General said this, that we're playing with fire. There can be no more playing for time. We're out of time. Closing the emissions gap, in other words, the emissions that are coming from the burning of fossil fuels, means closing the ambition gap towards the goals, SDGs and net zero, the implementation gap, and the finance gap. Right. So this notion of limiting the warming is an issue. There's going to be a struggle to even get to 2 degrees C, and the consequences of going to 2.6 are really, really very serious indeed. Now, all of this plays out in terms of natural products because of the sourcing of the natural products. That as soon, and we're seeing that in many parts of the world, as soon as you change any factor that involves the development of a natural product, in its environment, you change the metabolic profile. One of the things that's missing from this notion of 1.5 degrees C is that Earth is not an oven. So the notion that once you get to 1.5 degrees C, you can cut it off doesn't make any sense. Here's an oven, right? It's an old one. I used to have one of those, very similar. With an oven, you can reach a steady temperature and it can be turned down or turned off. The temperature changes, it drops. That's not Earth. When the 1.5 degrees temperature limit, quote unquote, limit is reached, imagine that was an oven, you can't just turn the oven off. You've still got 8.5 to 9 billion people at that time still creating heat from many, many different sources. So the temperature is still going to be rising. And I don't know the solution for that one. So the temperature won't be in the steady state for a long, really unpredictable period at this point in time, as far as I can make out. So let's just take a step back here and say, well, why is this so important for natural products? Well, look at what we use natural products for shelter, for furniture, clothes, resins, gums, waxes, flavoring agents, and spices that you use every single day, probably for every single meal that you have, the perfumes and the cosmetics, the prescription and OTC pharmaceuticals, the traditional medicines, the herbicides and insecticides, which we want them to be much more natural rather than synthetic because of the environmental issues there. And then, of course, we have to be responsible for the substances of abuse, which are, many of those are also natural products or synthetics based on natural products. So we're going to focus on the medicinal agents today. And our interdependence on these is sacrosanct. It goes back a long way in time, and it's sacrosanct. You have to remember that synthetic organic chemistry didn't develop until the mid-19th century. All medicines before that were natural. All medicines before that were natural. So how do we maintain this continuity with respect to the natural products that we need for society, as a base of society, for the extended period? Not for our generation, but for the subsequent generations. And to understand that we had a warning from St. Hildegard of Bingen back in the 11th, late 11th and early 12th century. The earth which sustains humanity must not be destroyed, for without it, we cannot survive. St. Hildegard was an amazing woman, and a naturalist, a composer, musician, and wrote a lot and did a lot. She was really quite stunning as a woman of her time there. So what is it that we have to maintain for our survival now? Those are going to be critical decisions that people are going to have to make, whether it's respect to plants, microorganisms, access to medicines. Another person who inspired me was Chief Seattle, who gave his name to the city of Seattle on the northwest of the United States. And in a meeting that he held with representatives from Washington, he made a lot of comments that, and I'll quote you a couple. Here's one of them. We do not inherit the earth from our ancestors. We borrow it. We borrow it from our children. I was inspired by that. And we'll come back to that in just a moment. Another quote from the UN Secretary General back in 2023 at the Economic Summit in Davos, the annual one. As today, fossil fuel producers and their enablers are still racing to expand production, knowing full well their business model is inconsistent with human survival. We're talking survival here. This insanity, his words, Here, this insanity belongs in science fiction. We must act together to stop our self-defeating war on nature. Right? So how close are we to this edge? And what's the edge? It's an acronym that I suggest. Experiencing the disaster of a gutted earth. And we're moving in that direction in many different areas. And I'll mention a couple or two just in a little while. So we move closer to the edge. And this goes to the State of Climate report. If anybody's interested in this area, this is a reference to bioscience. It came out in late 2024. And it's a very, very detailed report. It comes out every year by Bill Ripple, who's based in University of Washington up in Seattle, actually. We're driving faster and closer to the edge, to this gutted earth. Right here we are, close to the edge. And these are quotes from that article, that these are perilous times on planet Earth. And they talk about 25 of 35 planetary vital signs that were at record levels in 2023. So we'll see what happens when the report comes out for the next year. We're on the brink of an irreversible climate catastrophe. These are the words that are coming from, and this is a big group of scientists who've looked at this on a global basis. Another aspect that they bring up is the economic aspect and the relationship of the economic aspect to the resources that are available. In other words, the boundaries of the materials that we could possibly use for the future. And remember the comment about what we do for our descendants. Unlimited growth is a perilous illusion. We'll get back to that. So is mitigation possible? Well, he talks about that. That group talks about that. It talks about it in terms of there's no reverse gear, that the damage is already done, and the outcomes from the damage are still expanding. All right? Rapidly phasing down of fossil fuel use. That's going to happen in the next 20 years or so. All right? That's called defossilization. All right? And we're going to see just in a moment what that means for natural products and what we can do to make it work for us. Dramatically reducing methane gas emissions. We want to reduce those by 30 to 50% in the next 15 years. Drastically reducing overconsumption, which is one of the aspects of growth and one of the aspects of using up the resources. And what do we do about waste? What's waste? And how do we think about waste now? Skip that one. And also looking at reducing human population, because obviously the more people you have on the planet, the more of the resources are being used. And a lot of countries now are very concerned about their lower birth rates. Japan and Korea and China to a certain extent, and some countries in Europe, Italy, Germany, Switzerland, etc., very concerned about the rate. Also, there's a push now to increase what's called plant-based protein consumption, all right, from all those various food sources that are available. Now, sustainability is not a goal. Sustainability is the forever journey for humanity now. We don't have a choice. We don't have a choice. It's not an option. For too long, we've buried our heads in the sand. We've ignored it. We haven't realized how important it is for us and for our descendants, right? And Jack Welch, the former CEO of General Electric, many years ago said this, that face reality as it is, not as it was. We're not back in the 1970s or the 1960s or the 1980s or whenever you grew up, right? Or as you wish it to be. Maybe you wish it were like that. It isn't. It isn't. It's changed. Our actions and our research programs have got to acknowledge that. And that's the direction we're going to talk about now for the future. All right. Because what we do now is not going to have an impact now. All right. It's going to have an impact 5, 10, 15, 20 years from now. Before the tipping points, there are warning signs. Danger, wrong way, turn back. Danger, turn back now. Point of no return ahead. No turning back. This is where we are. This is how we're moving through Earth's resources, and we're getting to the tipping points. What are those tipping points? Well, one of them is the collapse of the big ice sheets from warming, and the warming is coming from the air and from the water, from the oceans. We didn't talk about the oceans, but there's a whole series of charts I could show you about the warming of the oceans, particularly the Thwaites Glacier. If you want to get interested in this stuff, this is crazy stuff, because Thwaites Glacier is about the size of Britain. And if that melts, then sea levels are going to rise several inches, maybe 6 to 10 inches. And think about what that means on a global basis. Think of what that means for the southern part of Pakistan, for example. We've got the widespread thawing of permafrost, which leaks more methane into the air, as well as CO2. The death of the coral reefs, and the collapse of this aromatic atmospheric circulation in the North Atlantic, which drives the weather systems for the eastern United States, for Western Africa, and for Europe, as well as northeastern Brazil. So that whole atmospheric circulation covers a lot of the world in terms of the ability to grow crops. Ability to grow crops is the same issue as growing medicinal plants, right? And then we get to the accessibility of fossil fuels. How long are they going to last? What are the projections there? And remember that once we've gone past these tipping points, it's not like a seesaw. You can put a balance on the other end and it'll come back. No. There is no reverse gear. Reverse gear is gone. We're only moving forward. We're only moving in one direction. So anything we do has to be preventative in terms of recognizing the proximity we are to the tipping points. In the next few years, you're going to hear a lot about these tipping points. So here we are. Let's look at the non-renewable fossil reserves here, a timeline. So here we are, 8.22 billion people on planet Earth, 2025. And you'll see when coal will run out, maybe around 2090, 2100, 2095, somewhere around there. Gas and oil, right? Gas, maybe 2060, 2059, 2060. Oil around 2053, 2054, somewhere around there. But remember, this is the end. This is the end. We're leaving nothing for our descendants. Nothing for our descendants. So even if we stopped now, that's whatever's left now has got to survive for the rest of humanity's survival. So we're in a very, very serious situation. Here we are, 2057. That's 30 years away. And we're going to be at 9.66 billion people on planet Earth at that time. And then what do we do? What happens when you get to this point? So there's 5 dominant factors for the development of natural products in society. And we need to be aware of these because this is how we have to program our research in the future. The first consideration is sustainability. As you start your research programs, particularly if you're thinking in terms of drug discovery or drug development, or as we're going to get to a little bit later on, replacement of natural products, your first concern has got to be sustainability now. If you develop a drug from a natural product source, is it sustainable? Is it going to be sustainable? Because otherwise you don't have a product, right? And then whether that's coming from a traditional medicine or whether it's a synthetic, because remember that we're going to have an issue with the sustainability of synthetic medicinal agents. Environmental change. So from a traditional medicine perspective, we know that as soon as you affect the environment, metabolite profile changes, which means the biology changes for a traditional medicine. What does that mean for the patient? Remember, we're thinking patient first. How do we begin to control that for the patient to make sure that they have a consistent product? Defossilization. Some of the materials that we think are always going to be available are not going to be there. We need money and we need time because the time is running out. And so the sooner we get going on this stuff, get some action, get some investment, and make sure that we can challenge these issues that I'm going to explain to you in a little while, that's when we're going to start to see natural products and the role of natural products in society with respect to medicinal agents develop. Because remember, without the natural resources, there isn't a system, right? So I've been concerned about this for some time. And as I mentioned, Chief Seattle was an inspiration. And I wrote an article, not for us, but for our descendants. And I wrote that article in 1992, so 33 years ago. And it was published in the Thai Journal of Pharmaceutical Sciences. So I wrote it in 1991. And it said this: preserving indigenous knowledge, in other words, about traditional medicines, developing our resources in a sustainable way, and potentiating the richness of our biological and cultural wealth is the ultimate gift we can offer our descendants. All right, that's our ultimate gift, to leave them material that they can use, and they're going to have to leave it for the subsequent generations for them. All right, so how do we do this? How do we minimize our use of the resources? Because we've done so many things to eliminate that. Now, we've got two major myths that relate to medicine's access. All right, one of them is this: that the plants will always be there. We think in terms of traditional medicines or all the other aspects that we use plants for, that unless they're cultivated, they're not always going to be there. And even if they are cultivated, they might not be there because of fire, because of drought, because of flooding, right? So how do we assure that those are going to be available for it? And the other one now, based on the defossilization that's going to be taking place, is the chemicals will always be there. Will they? I'm not so sure. And if they're not, what replaces them? How does that happen? Where's the research initiative that's going to lead to that replacement step for synthetic medicinal agents? How's that going to work? A lot to be discussed here. The problem here is also that remedial actions cannot occur while the reality is denied. In other words, if you maintain the myths that the plants are always going to be there, the chemicals are always going to be there, you're never going to take the action that's needed to solve the problem. So another acronym: healing the earth is critical for our survival. Remember St. Hildegard of Bingen. So harnessing Earth's assets leads to inevitable natural gifts. So this is what we're about now. It's a part of developing a healthy Earth, all right? That we're not abusing the Earth. We're harnessing the Earth's assets, all right, in a sustainable manner, in a healthy manner. Because for millennia, we've turned to nature, and it's provided us with all we've needed to develop life as we now know it, all right, in our present, wherever we are in the world. That period has ended, all right, gone, all right? You may be living it, but the reality is a little bit different. Now we have to face a reality which requires that we optimize what remains as a gift for future generations. This is very, very different thinking, all right? It's saying we can't go on as we have been doing so for the last, maybe 150 years or so. No, we're now at a point where we have to optimize, where we have to really think about what it is we're doing and how we're doing it. And we talked a few years ago, this goes back 18 years, when I wrote an article with a dear colleague, Mike Colvard, that talked about the balance of resources and their use is no longer in our favor. Restoring that balance is likely impossible. In other words, we can't go back on this. I mean, yes, you can do replenishment activities, and yes, you can replant and so on and so on, but it doesn't really take us back once you've destroyed major forests like in the Amazon or on the west coast of Nigeria and wherever. It's time for the healthcare industry to think in terms of medicinal agents as a sustainable commodity, right? That the synthetics and the natural products that are used as medicinal agents as sustainable, right, in their provision to the global population, and in a manner that does not deplete the resources of the planet. We were talking about this 18 years ago. We have a partnership. Most of you, when you get up in the morning, right, I'm sure one of the first things that you grab is your smartphone, right? That's your link to technology. It's the first thing you do in the morning, and it's with you all day, and it's probably in your right or left hand most of the day, and you put it down and you're looking at it and you're checking it. That's only part of the balance. All right. Yes, it's wonderful technology, and yes, it's going to be absolutely critical for us in the future as we're optimizing our gifts for nature. And we need those gifts, that nature has gifts for us that we have not explored, properly yet. And we're going to be doing that. We're going to have to. What we have to do is to restore that balance through love. Through love. So what's love? What's L.O.V.E. I introduced this about 4 or 5 years ago. Love is learning to optimize the valuables of Earth. That's what we're about now. We have to optimize whatever we come across that's going to be valuable to us. We have to optimize that. And we've been doing that for millennia. That's how we discovered all these medicinal plants. It's how we discovered the best woods to use for construction, for a cricket bat. All right. What's the best wood for a cricket bat? Yeah. You do it through trial and error. You do it sustainably. That's our reality, optimizing what we have. One of the challenges, of course, now, if we're going to optimize what we have to know what's there. Now, Kew Gardens, the Royal Botanic Gardens, Kew, every couple of years, they put out a report on the state of the world's plants and fungi. So, and they also run this medicinal plant name service, which if you're working on natural products from plants, you have to use to authenticate your names. Now, so they say there's 391,000 plant species, okay? And 28,187 of those are medicinal plants. About 38% of all tree species, according to IUCN, are threatened with extinction at the moment. So we're going to lose about a third of those. But what actually exists? That 391,000 comes from herbarium records. It doesn't come from field work. It comes from herbarium records. So how many of those actually exist now? Where are they? And how do we know? How do we know where they are? Because if we're going to use natural products, particularly plants, as a resource for the future, as we develop new programs, and we'll get to those, you have to know where they are. So one of the areas that is under rapid development now is the use of drones, of course, in ecopharmacognosy. Ecopharmacognosy is making pharmacognosy, study of natural products from medicine, from nature, making that sustainable. So the idea is, of course, you fly over a forest, right? And you use your drone, coupled with AI and machine learning, to do medicinal plant identification, monitoring the distribution, and monitoring the growth of the plants. So that might be one approach to find out where the medicinal plants are. We've got to know. We've got to have some access to the information, not just of where they were, but where they are, that can be resourced in a sustainable manner. So what we're doing is we're looking at paradigm shifts here for medicinal agents, not thinking about the current ways that we develop medicinal agents, but thinking about new ways that are going to be forced on us through the defossilization program. So love, optimizing these valuables of Earth, is not an option. It's not an option now. It's now our forever pathway. And it's a moral obligation to future generations, because otherwise they won't have the resources. We will have used up those resources. We used to think of nature as a reservoir, usually an untapped reservoir of biological agents that needs exploration. No. Yes and no. Yes, that's true. And it's the way to produce them for the future. That's why it's so important now to have natural product scientists, the young scientists, be developing new thinking about where those materials are going to come from in the future, and being aware of the history of where we're at, how we came to this point, and how the inactions of so many people around the world with all these meetings that I didn't get into, that didn't describe, really at all, how it's led to this point where we're on a timeline. And actually, I talked about this a long time ago, 2011, that plant medicines are the key to global health. And it's becoming a reality now that strategically, how we proceed from this point is going to be critical in terms of medicines, not next year, not for 5 years now, from 10, 15, 20 years and beyond. Another quote from Chief Seattle: "Humankind has not woven the web of life. We are but one thread in it. We're not separate from. So whatever we do to the web, we do to ourselves. All things are bound together. All things connect." We're seeing that. We see that on a day-to-day basis now. So let's go back to medicine security. Medicine security is an example of putting the patient first, right? And I first started talking about this, it's now 8 years. Just about 8 years ago, I started talking about medicine security. It's quite amazing, because there is no international agency for medicines which corresponds to the FAO, the Food and Agricultural Organization, which is a major UN agency all over the world for food. There's nothing that corresponds for medicines, for healthcare. That's not a responsibility of WHO, for example. It's not in their constitution back from 1948. So what is medicine security? What does it mean? That the medicinal agent will be sustainably sourced and manufactured under GMP to be consistent. That's what the patient wants, consistency. The product will be authentic, and WHO is concerned about that, correctly dosed, and we get into that issue when we start to deal with traditional medicines, not adulterated or contaminated, no synthetics in there, no other plants in there, and maintain quality, safety, effectiveness through consistency. That's what the patient wants, right? The product will be accessible, available, and affordable, and be marketed with claims that parallel the positive biological assessments. All right. And all the time, all over the world, you see claims made for traditional medicines, for example, that are just completely absurd. They're like every, a medicinal agent from a plant is a panacea. No, it isn't. It isn't. And be careful what you claim about a biological activity. All right. There's too many papers that I read where it's a lot of hyperbole. One cytotoxicity as does not a cancer chemotherapeutic agent make, for example. This supports a patient-centered approach, and it supports it to what really becomes a third class of nature-based drugs. And there's some countries around the world that are working on this. What else is medicine security? It's security in the sense that the data associated with the creation and use of the product will be held with resilience. Resilience comes from fifth industrial revolution. Go back and check what the difference is between the fourth industrial revolution and the fifth industrial revolution. They're completely different in terms of their focus. Fifth industrial revolution is very sustainability oriented, human oriented. Fourth industrial revolution, production oriented. The need for bioprospecting, that patients, science, physicians, governments need to know that the development of new human and veterinary medicines for drug-resistant organisms, neglected diseases, medicines replacement, which is going to be very important, changing levels of disease prevalence from climate change, and new biocides that are natural and sustainable and not synthetic, is recognized and is acted on. Not just that the problem exists, but it's actually being aggressively addressed. All right, that's where we're at. Some other dominant factors. Because we know when we've got medicinal plants, for example, that hotter or cooler changes the metabolite profile. Water, more or less. Increased salinity. Remember, we've got sea rise happening all over the world at various levels. There's islands in the Pacific that are going to disappear, nations that might disappear in the next 40, 50 years. All right. So any area that's close to the coast is going to be inundated to a certain extent. And obviously some major cities in Asia have already decided to move. Jakarta is moving to Borneo, to a completely different island in order to be safe. Carbon dioxide levels higher. That changes the pH of the ocean, which means you're, as well as the warming factor, you're changing the environment of the coral reefs, which has a major effect. Altitude. We've got plants in the Himalayas that are moving to higher ground because they prefer a cooler environment. The disappearance of chemicals, plants, and the need to find a new source if you're going to replace those plants in the medicinal milieu of your healthcare system. And then you've got different levels of biomass production. And what does that mean if you've got smaller biomass in terms of the metabolite level, and therefore the dose that you would be giving that medicinal plant? How do you control that? How do you get the consistency? So the amount of work that's needed here from a natural product development perspective is very, very significant. These outcomes are not predictable. In other words, you can't always say that with more or less water, you're going to get more or less metabolite. So it requires individual research. So let's look at defossilization, medicine security, and biological agent replacement. Defossilization, that the supply of chemicals that are going to be needed for solvents and medicinal biological agent synthesis will be reduced over time. And I wrote about this in this article from 2024. So strategies are needed to develop sustainable methods to replace on a prioritized basis, because we're not going to be able to do everything, selected agents, and then develop new agents as needed, all right, to fill some gaps. And recognize it's also a bio-waste opportunity, right? But it's going to take time. It takes time to develop a drug from the bench to final approval, depending on your system, could take 10, 15 years. So that already takes us, even if we started tomorrow, that already takes us to 2040. We're getting near to what's supposed to be net zero in 2050. So long-term challenges for a country. How to balance the importation of allopathic drugs, develop a pharmaceutical industry that's going to be responsive for the new era of medicinal agents, develop generic substitution, and provide safe and effective traditional medicines in a sustainable, quality-driven, and affordable manner, optimizing the use of local resources to meet the patient needs. These are major challenges for natural products research, right? We've got a lot of challenges ahead. To give you an example of the issues that Pakistan is facing, by 2050, Pakistan's population is projected to increase by 46%, 372 million. Moving it up in rank, it's presently rank 5. These data I took just a week or so ago, to be ranked number 4. By 2100, it will be ranked number 3 in the world. And the population will have doubled compared to your current population. So what does that mean in terms of medicine security, medicine supply? Someone needs to be planning. So our challenge is, from where and how will the bioactive natural products originate to meet population needs? And how does this mesh with everything else that's going on? Because we've got lots of other considerations here. We've got fifth industrial revolution, sustainability, environmental change, devascularization, and degrowth. So in terms of drug replacement, medicine security aims to keep as many of the existing drugs as possible available because they've demonstrated efficacy. So you want to keep those that work. You want to make those a high priority for replacement. That means exploring new synthetic routes, having minimal requirements for fossil fuel generated precursors, all right? Reagents and solvents. This is beyond green chemistry. This is 1 or 2 stages beyond green chemistry in terms of the impact on the nature of the research that you're thinking about. Pursuing sustainable bioactive replacements which are natural or semi-synthetic, right? That's going to be one of our major goals now in the future. So applying the principles of love, optimizing those valuables of Earth. So this was the article that I published early 2024, Contemporary Nexus of Medicine Security and Bioprospecting, putting this story together, as it were. So all of these are meetings that the COP 28, 29 are about climate change, COP 15, 16 are about the issues with biodiversity and conservation. And how does that all mesh with the SDGs? So we've got enhanced and very exciting AI and ML space roads for natural products. Right? Those are roles that are going to be very, very important beyond 2050. Looking for standardized and sustainable traditional medicines, making that a focus for the healthcare system. Right? Standardized meaning it's for the benefit of the patient. That becomes as a priority. New bioactive natural preparations and compounds. Right? So that's basic bioprospecting, drug discovery aspects. Replacing the synthetic bioactives with sustainable compounds and creating approved and new agents from bio-waste, right? From bio-waste, and we'll come back to that. And obviously using the AI and ML systems in terms of in silico chemical space explorations. What can we be doing with substrate specificity for certain enzymes? All right, what can we do with changing the individual amino acids in an enzyme and looking at that, the effect of that on substrate specificity? That's ongoing work. It will be more intense. Enhanced chemoenzymatic synthesis. In other words, can you put together a whole scheme of enzymes that are sustainable, right, for the synthesis of key drugs? And can that be scaled up? That's the issue. Take it from the lab to become production scale activities. So what's waste? So waste, interestingly, has several implications, right, in English. There's waste in terms of goods, in terms of food, in terms of effluents that come out of factories, etc. And there's waste in terms of money. We waste money, of effort, excessive indulgence. We eat too much food, of aging, and the so-called seven wastes of being manufactured. There's also waste in terms of time, and we've wasted a lot of time. There's this expression, and I don't know how many of you grew up with this expression. I grew up with it in England for sure. Well, waste not, want not. And it actually comes back from the 16th century, from the paradise of dainty devices. For want is next to waste, and shame doeth sin into. As the finite resources are diminished, remember, we're not wasting these resources now, we're optimizing them. Different philosophy. Love requires a deeper recognition and action to explore the functional potential of waste, right? Lest future generations want for that disappeared resource. So some of the kinds of waste that we have here, we've got natural bio-waste, chemical waste, discarded fabrics, electronic waste for the recovery of precious metals. Lots of people are working on how to do that, and whether natural products can be useful there in terms of siderophores, which can accrue particular metal ions. And that's a whole other big topic. So waste now, what we call waste, must be seen as a starting material, not as a linear end product, right? Because usually we're make, use, throw away, waste, right? It's usually that linear model. No, change the model because it's an essence of love, all right? It's optimizing. How do we optimize? We optimize it through a circular economy where we're using the waste probably through enzyme activity or through microbial activity to develop materials that are coming from the waste, right? Particularly food waste. So we're looking at bio-waste to biomaterials, from chemicals, enzymes, polymers, fuels, through microbial transformations or enzyme transformations. So let's look at a couple of examples. One of them came out recently, 2024, late 2024, of generating paracetamol from poplar tree and palm oil bio-waste. All right. So what was done was this conversion process to take the biomass, to treat it with ammonia and get parahydroxybenzamide, which undergoes Hoffman rearrangement with sodium hypochlorite and gets you to para-aminophenol. Acetylation gives you paracetamol. Right. So here's an example of going through this process from bio-waste to an actual drug. There's ways to improve this, but this is a start. What was interesting in the paper was that they took it beyond this step because they talked about the detailed discussion of the economics of the process. In other words, they took it to the point of, okay, what if we try to make this practical in terms of the economics? Another one that came out in 2023 was looking at lignin, and lignin is the major bio-waste material in the whole world, probably, and doing depolymerization, and there's various ways you can do this. And one of the compounds that comes out of this is what's called the C2GEG acetal. It's compound in the middle here, all right? Because that has a lot of potential. It's a dioxygenated phenylethanol derivative and protected as the aldehyde. You can take it back to the alcohol, you can take it to the aldehyde. And that, of course, because of the nature of so many drugs, many of which have this 3,4 dioxygenated C6C2 scaffold, all right, if they're coming from natural sources. So it was actually used as a precursor for a couple of natural products to develop dopamine, straightforward, in order to develop in pretty high yield, 89% in 6 steps, tetrahydropavirolene. Right? So you've got the potential there to take lignin, depolymerize, and come up with a synthetic intermediate that has diverse applications. So where are we going to be for 2040? This is where we're at the moment. We've got our current agents that are synthetics and natural products. We're going into a period of defossilization. But 2020, 2040 and beyond, we're going to be dealing with natural resources optimization. All right, we're going to have to be at that stage after the defossilization has really kicked in. The way to supplement this is obviously from bio-waste and various conversions of various forms of bio-waste, whether that's residue from nuts, residue from the tops of pineapples, whatever it is, developing compounds from that. Then going to the step where natural products chemistry is going and biology is going to be really important. This notion of developing replacement agents, because it's those replacement agents that are going to develop medicines security. So where are we now? We're back to where we started. Go back to that core question. What's going to be the origin of medicinal agents? Well, I've tried to show you what some of the choices are going to have to be very seriously considered. And then beyond 2050, 2060, for even greater populations when we're closer to 10 billion people on planet Earth. So we have a very exciting future for natural product sciences. Integrated AI/ML systems for locating plants, relating compounds, and the biological effects, the enzyme level. Automated isolation, co-robots to be able to do that, and structural elucidation. It's just a question of time. Robotized chemoenzymatic synthesis based on machine learned optimized pathway design. That's already going on in the synthetic chemistry area. We're going to develop it for chemoenzymatic synthesis, and in vitro total synthesis of replacement natural products based on sustainable enzymes. Some more examples. Field-based remote sensing analysis of the location and quality of medicinal plant, so that you're optimizing the collection of the plant at the point where the likely yield of the bioactive agent is optimized. Enhanced traditional medicine safety, efficacy, and consistency. That's a standardization protocol, taking it beyond the issues that relate to pharmacopoeias and so on and so forth. We need to go to a different level there. Bioassays for neglected diseases coupled with AI and ML in terms of sourcing, expanding natural product structure diversity through substrate enhancement. So where are we here? Well, this is how it used to be. And the American poet Robert Frost wrote a very famous poem about this. Two roads diverged in a wood, and I took the one less traveled by, and that has made all the difference. Yeah, fine. We don't have another road now. Our road is something we have to carve out ourselves, right? That's our way forward. Our way forward is into a forest of the unknown, right? So now for humanity, there is no less traveled road that we can pursue. The future is a new and unexplored pathway, and we can only imagine what the outcomes of failure on that pathway would look like. So for our descendants, all of them, however many generations it is, we must succeed. Thank you very much indeed.
Thank you so much. Thank you so much, Professor Jeff, and for this very inspiring and eye-opening, I must say, the topic which you have chosen for us to enlighten us for the knowledge you have given to us. Thank you so very much. We know that it's midnight in Chicago, and you are giving us this lecture, inspiring lecture. We are so much thankful to you.
Oh,
So
no,
with that,
that's
I
my
would
pleasure. That's
like
my pleasure.
Thank you. Thank you so very much. So with that, I would like to open this session for some quick discussion or maybe some question from the audience so that as I see like the topic is very much interesting to all of the audience because they are the PhD students and they are mostly working in the field of chemistry. So anybody who has a question?
Let me just say something about that because
Okay.
it's important. Let me make another comment outside of the lecture with respect to the students. Because the issue here is when you're a student, you sometimes, I think, focus on your research, rightfully so, and aren't aware of some of the other issues that are going to be important for you after you've graduated, after you've got your PhD, and coming to the point of saying, well, now what am I going to do? How am I going to benefit society? What are the priorities? And obviously, you don't develop the priorities in a way. It's the government that develops the priorities. It's the funding agency, whatever country you're in. It's industry that's developing the priorities that you fit into. So, but being aware that these are issues, and at the times, as Bob Dylan used to say back in the 60s, the times they are a-changing. The times they are a-changing. They are changing a lot. And student thinking has to change a lot in concert with that.
Yes, agree. Totally agree. Yeah. So, sir, would you like to have some comment on that? Our director would like to say something.
Yeah, any questions?
Yeah. Geoffrey, thank you so much for such a eye-opening lecture, and really we didn't thought that what we are doing to our planet and what are our responsibilities, and the major problem is that the lack of the awareness,
Yeah, that's right.
especially, and the prioritization of our politicians and also the scientists. And your lecture is a very timely lecture, in the sense that in the United States now there is a new government, and again. Uh, in order to sensitize the issue, just the importance of sustainable goals and the role of the natural product chemistry, and especially we are eating our meager resources,
Yes,
and we are not aware that what we are giving or what we are leaving for our children. And
yes,
that is a very important issue that we should sensitize that whatever we are doing today, the consequences will be bear by our children. By and that is we should think about just leaving a good planet for our children, and also we should just not talk about these issues in the scientific forums, but we need to just take on board the society,
absolutely.
because the researchers and the scientists, that's a very minor part of the society, and but the role of the scientist and the researcher is more important than ever now, and because we are now aware that the natural resources are diminishing with the passage of times, and nobody is aware of that what we are going to, and what these the pharmaceutical industries, they, you rightly mentioned in your lecture that they don't care.
No,
they
no,
they are more concerned about earning the money now, and just they don't care about those diseases which are important. Probably they would care more about those diseases which can just generate more revenue. But
absolutely.
all these neglected diseases are the poor man diseases. These are not interest for our pharmaceutical industry, and I was just thinking, and I was just want to get your opinion that from the platform of UNESCO Chair and the Chemical Society of Pakistan, what we can do that just presenting, especially in Pakistan, main points to the Planning Commission of the Pakistan,
Yeah,
that you
yeah,
see that being an important player in the global arena, that we should, while funding the projects, giving away the money for the research and development, we should also keep an element that we should preserve our nature. This is our collective responsibility. We should not leave this responsibility for the richer countries, because this planet is for all of us, and that is what we can just present to our government, and just see that you should also just keep an eye on this, and while funding the projects and initiating any kinds of programs, there should be built in these questions, and they should ask these questions: what kind of remedial actions will be taken while initiating projects? And that is the important, because this world in which we are living, it's not an oven. We are increasing the temperature, and this temperature is irreversible. So, and Pakistan is affected last year by the huge flood, and the main
Mhm.
reason is this climatic change, due to that these various kind of activities is happening around the globe, and we being a Pakistani, like most of our rural areas, and especially in the villages and in the Sindh province, many of these villages were just drowned, and we had to spend a lot of our revenue to just in their rehabilitations. And so this is actually, we are living now in a global village. We cannot be irrelevant. We cannot just stay silent. And that we should just also sensitize our government, and we should just
Well,
create awareness of
yeah, I
something.
mean, I think that's one of the functions of UNESCO, to bring these kinds of issues together on a global basis. And one of the persons who is kind of my hero is the United Nations Secretary General, because he gets it. He really gets it. I mean, he says, we're out of time. He says, what's going on is insane. So he really understands it. But there are other forces at work that are very, very powerful. And you mentioned one of them. One of them is pharmaceutical industry. They don't want to tackle these issues. All right. We know they're not tackling the issues of medicinal agents in a constructive way, for the health of the world. They're looking at it in a very narrow focus of where, as you rightly said, where they can make their money. So I mean, you're raising a whole series of very interesting issues, particularly that relate to how it's and what's the strategy to get the information, to get the awareness in a very different place, a place where it can, as you were hinting at, be acted upon as a healthcare need for the future for the country. Because most countries, they're operating on a five-year strategic plan or something like that. This doesn't cover that. All right, it covers a little bit of it, but really you're looking at a much longer term plan. You're saying, well, where are we going to be? Where are we going to be in population? Where are we going to be in medicine accessibility 10, 15 years from now? What are we going to be doing? Who's thinking about that? What's the plan? Well, you have resources, right? And one of the things that I've talked about in some other countries and said to people there, I've said, put together a white paper from the natural products group, whatever that group is in the country, that says, here's what we can do. Here's what we're willing to do. All right. Because we're willing to change. It means changing direction, because it means saying that it is doing what I started off by saying, putting the patient first, not doing what happens to be an interesting academic research project, but saying, no, we want to help the patient. All right. We want to standardize traditional medicines. We want to develop new ones. We want to develop replacements for synthetics. We want to find sustainable resources for our plant materials. We want to make sure that the various forms of traditional medicine that are operation are appropriately standardized. All of that is within the hands of the natural product community. All right. There's a term that I developed a few years ago called cyber eco-ethnopharmacolomics, which is an integral approach to this bioprospecting, and ends with an omics. You know, and there are many omics. There's taxonomics, metabolomics, and so on. But the key one is economics, because it has to be affordable. It has to be affordable at the end of the whole process. But it's making that pitch to somebody somewhere in the government to say that the natural products group in the country has gotten together, has thought about the issues and said, we can address this. All right. We can help society address these major issues that are going to be forthcoming, because the present system, this linear system, is not going to work. We're going to have to go to some kind of biocircular economy in order to respond.
Thank you. Yes, totally agree with your point of view. And as you rightly mentioned about, I think it's a good activity from UNESCO platform to produce a white paper for the stakeholders in the natural product chemistry to present to the government and then ask them to do the needful, you know. So thank you so very much, Professor Cordell, for giving us so enlightening lecture for and giving us awareness about this topic. So with that, we conclude today's lecture. And thank you so very much. And we wish you the very good sleep and a good night. And in future, we will have more interaction with you on the from the UNESCO
Okay.
platform.
I will look forward to that.
Thank you so very much.
Thank you, everybody, for being there, for participating. And I hope this was useful, and I hope it got you
Definitely,
thinking
yes.
about the world that we're living in now. So thank you very much indeed for the opportunity, and I wish you all success. Thank you.
Thank you so much. Take care. Good night. So with that, thank you so very much for everyone to come in and then take this lecture. And we'll see you in future as well. Thank you so much.
Yep. Thank you, everybody.